Okay, 4.3, we are going to solve homogeneous linear equation with a constant coefficient, okay? So that's it, homogeneous. Okay, homogeneous linear equations at one condition, constant coefficient. With this method cannot be applied if the coefficients are not going to be constant. Okay, with constant coefficient. So this is the target. We're going to study this type of equation. Okay, first, the general form. Okay, this is it. So consider this equation. Consider the second order. Okay, second order different equation or differential equation. You see the form? It's going to be A is a number, Y double prime order, second order, plus B Y prime plus C Y equal to 0. This is going to be the case where A, B, C are going to be constant. Where A, B, and C are going to be constant or constant number. So this is the equation that we're going to be interested in. Okay, that's going to be the one. So you know something like 2y double, it's like a quadratic equation. 2y double prime plus 5y prime plus 10y equal to 0. Now, in order to solve it, we did see something right at the beginning. You see, since this is just a function and its derivative and a number, so you should look for a function whose derivative is going to be multiple of the function. So the candidate is going to be exponential function. So we assume that, assume that we did this one before, assume that y equal to the e to the rx, r is a number, is a solution of the equation when r is a number, when r is going to be a number. So if this is going to be the solution, it must satisfy the equation, So it must satisfy the equation, so find the derivative. So the function is y equal to the e to the rx. The first derivative, exponential function never change. You have to find the multiply by u prime. So it's going to be r e to the rx. And the second derivative would be, r e to the rx again, it's going to be r squared, e to the rx. Since you claim that this is a solution of the equation, so it must satisfy the equation. So substitute into the equation. So if you substitute into the equation, is going to be a times y double prime is going to be r squared e to the rx plus b times y prime r e to the rx plus c times y c times e to the rx equal to this. So that's going to be the case. Now you know that e to the rx is never 0. So divide. E to the rx is never 0. So if you divide, so that give you ar squared. We just divide by e to the rx. So that give you ar squared plus br plus c equal to this. You see, you arrive at this equation. And this equation can form right away. You see, look at the given one. This is ay double prime. It's going to be ar squared plus br plus c. is like r squared, r to the first power, and r to the 0 power. R to the 0 power is equal to the 1. So now, as you can see, if you call this equation star, so this is a quadratic equation. If you solve it and get the r, then e to the rx is going to be a solution of the differential equation. So we find a kind of one-to-one correspondence between the solutions of the differential equation and the solution of this equation. This equation is going to be called, you see, a star is called, okay, they call it auxiliary equation, but the better name is characteristic equation, okay? So a star is called the characteristic equation. Characteristic equation. Okay, characteristic equation of the differential equation. Of the differential. Okay, of the differential equation or auxiliary one. So note that this is going to be the case. Y equal to the e to the rx is a solution. Okay, is going to be a solution of the differential equation, if and only if r is a solution, is a 0. Is a 0 or is a solution? Is a 0 of the characteristic equation, okay? Of the characteristic equation or a star. Okay, now you know that a quadratic equation would have, you want to solve a quadratic equation, there are going to be 3 possibilities. You may solve it to get 2 different real solutions. You may solve it to get 1 repeated solution, or you may solve it to get 2 complex solutions. So according to those cases, we are going to identify what is going to be the solution of the differential equation. Okay, so you know that in general, you can solve this equation by using the quadratic formula. Okay, so this is it. There are 3 possibilities. 3 possibilities. Okay, case 1. Case 1, we call it distinct solutions. We call them distinct because we are going to extend this one into the higher order. Okay, distinct means different. Distinct real solution or real roots. It refers to the roots and the 0 for the, okay, for the characteristic equation. So suppose you solve a star and you get 2 solutions, okay? So this is it. If R1 not equal to the R2, okay, are going to be solution or 2 solution, 2 distinct solutions, okay, of the star equation, characteristic equation. You know that. Then each of these, then the corresponding one, then one of them, we call them Y1 equal to the e to the R1x, and the other one, Y2 equal to the e to the R2x. Automatically, they are going to be solution of the equation or solutions of differential equation. Okay, or 2 solutions of the differential equation, and you can check it with automatically. If you check the Wronskian of Y1 comma Y2, is not going to be 0. It's easy to find. Okay, the Wronskian will be just e function, e to the Rx and e to the Rx is never 0. So since there are two solutions with a non-zero Wronskian, you know that they are going to be a basis. So this is going to be the case. Therefore, we're done. Y equal to the C1 Y1 C e to the R1X plus C2 e to the R2X is going to be the general solution. Is going to be the general solution of the differential equation. And with that. So for each distinct roots of the equation, you have one solution. So this is the equation of the second order. You get two solutions. If you have the equation of the fourth order, you may have four solutions. It doesn't matter. For each one of them, you get the R over there, you get e to the Rx over here. You just get the combination, linear combination, and you go. So we do it for two, but we are going to give a couple of examples, and it's going to be higher order. That's the case one. Any question? So quickly can be checked. Okay. This quadratic equation, be ready for it. Sometimes the solutions are not nice. You may have to use quadratic formula to get it. Okay. But it's possible to find the solution all the time. That's case one, distinct solution. Case two. Case two, you may try to solve it and you get only one solution. Remember, repeat the solution. You know that if delta is equal to 0, b a squared minus 4ac, which is the discriminant of the quadratic equation. If that's going to be 0, you're going to have the repeated solution. You have two solutions, but they are the same. Okay? If you get a two solution, if you get repeated solution, we call it R. Quickly, that gives you one solution, e to the Rx. You need the second one. How are we going to find the second one? Reduction order formula. By the reduction order formula, if you check it, in that case, x e to the Rx is the second solution. You can use it anytime you like. You can check it for it. That's why we talk about that method here. So one of the solution is going to be e to the Rx. The other one will be x e to the Rx. You know that the solution that coming from the second or reduction to order by the round scale, remember, they are independent. So quickly we get the solution. C1 e to the Rx plus C2x e to the Rx is the general solution of the equation. Okay, so that's it's a case two. So the case two, repeated solution. Okay, repeated, of course, real solution or solutions. So in this case, if we have solutions are the same, if R1 is equal to the R2, we call it R, is a repeated solution, is a repeated solution. Okay, then automatically you get one solution. Y1 equal to the e to the Rx is going to be a particular solution, is a solution of the differential equation. This is one of them. And we can use, it can be proved or shown, okay, by the reduction order method, that y2 equal to the x e to the Rx. We multiply by x. Is going to be the second solution, okay, is the second solution of the differential equation. So we have the general solution. So y equal to C1 e to the Rx plus C2x e to the Rx. Okay, this is going to be the general solution of the equation. Is the general, okay, the general solution of the differential equation. So, because we proved everything before, nothing to worry about. You get this one right away. We do the same thing in discrete mathematics. You don't have the reduction of the order, but since you're working with the sequences, it's easy to substitute together. But the method is going to be the same. Okay, that's a case 2. Again, this is a second order. When it's a second order, this is going to be repeated only once. Okay, but you may have a higher order. If you have a higher order, you may have, you may have a solution that's going to be repeated twice. You try to solve this equation, you factor it, you get r minus 1 cubed equal to the 0. So you get only one solution, but the order is 3. So what you do is you need 3 solutions. E to the rx, x e to the rx, you multiply by x again, x squared e to the r. You get 1, 2, 3. You want the 4, you can do it. So easily we can, we can get all of them. So that would be the second case. Any question? Now the third case. The third case is you try to solve this quadratic equation and you are going to get complex solution. Okay, we solve and we get all the solution. In the application problem, most of the time it's all complex solutions. So that's going to be the case that we're going to have. Okay, so we're going to consider it. If you are going to be discrete mathematics, you can have the complex over there, but they don't usually consider it. Okay, they go with the real. But we are going to go to the third case. Okay, the third case, complex solutions. Okay, so it's not the case that you say there is no real solution and you stop. You have to give us all the solutions. Okay, case 3. Case 3, we call it complex solution or complex roots, if you like. This is it. Okay, complex solution or roots. You know that each complex number can be written as, we call it, a plus bi. We go with the alpha plus beta. The solutions of the equation, when a solution of a question, solution of an equation is a complex number, this solution would come in pairs. So if, for example, if 1 plus I is one of the solution, automatically 1 minus I would be another solution. You know that this is true for any equation. If you have any equation, all the complex solutions are coming in pairs. And so your solution automatically would be alpha plus beta. Okay, you can use the so-called the Euler formula. You can use the same thing. You can form e to the rx. But since it's a complex numbers, we have, if you remember, we have something, we call it Euler form, or we can call it the trigonometric form of a complex number in terms of the cosine and the sine. So that's why the shape is going to be different. So I explained that one. And you can stay with that e function, but this is the way we're going to do it. So complex case. The complex case are going to be in pairs. So if R1 is equal to, we go with the notation of alpha plus beta I or I beta. This is one solution. Automatically you get the second one. And R2 is equal to the alpha minus beta I. They are going to be R2 complex solution, complex roots, okay, of that equation that we have. Now you can, can use a little bit of Euler form. Just remind you, note that this is the Euler form, because you can do e to the rx again. You see, if you have e to the alpha plus beta I, if you like, you know that the way we write this one is we break it into the e to the alpha, then times e to the beta I. And for that beta I, we use the Euler formula. So the Euler formula is going to be, this is going to be the cosine. Okay, the cosine of the beta plus I sine of the beta. So that's the Euler form of this exponential function. So it's a e to the rx again, but if you put them together, So if this is going to be, you don't have to consider positive, negative. One would be enough. So if you take your R to be alpha plus beta I, then your solution is going to be what? Y is going to be e to the Rx. So that gives you e to the, okay, it's going to be alpha plus beta I times x, which is e to the alpha x plus beta x I. So if you do exactly what I did on the top, it's going to be e to the alpha x, e to the, okay, beta I, beta times that beta x. So beta x times I. So that gives you e to the alpha x times cosine of beta x plus I sine of the beta x. You see, that would be the shape of the information that we're going to have. So since we are looking for two solutions, so the solutions are going to be this one. Okay, so this is it. Then we're going to have the y1 is equal to the e to the alpha x cosine of the beta x, one solution. And the y2 is going to be e to the alpha x sine of the beta x. Okay, you don't have to repeat it with the alpha minus beta I because they're going to be all the same. And when you bring the constant, there is no difference between alpha plus beta I or alpha minus beta. Okay, so therefore, this is going to be the final, the general solution. Y equal to cy1 plus cy2. It's going to be c1 e to the alpha x cosine of the beta x plus c2 e to the alpha x sine of the beta x. So this is going to be the general solution. Okay, is the general solution is going to be the general solution of the differential equation, That's it, 3 different cases. If it's going to be the higher order, we can cut it. Yes. This is that? Yeah, x is related. In red x, okay, so that's going to be 1. We try, of course, not to use the decimal numbers, okay? And it's given to you, it's going to be in terms of the pi. Unless it's a very bad angle, okay, it's going to be a numerical one in application problem. We can use that. So that's it, different cases that we have to plan. 3 cases, you need to operate. So the equation will be given to you quickly. You change it into the characteristic equation, solve it, 3 cases, list the solution, and then you're done. So write it down, give you an example how we're going to work with it. So that would be homogeneous one. Okay, then we can try the more general one. So we give you 1 question. It's going to be something like 3 parts, 2 questions for these numbers.
Professor?
Yes.
Right before the line where we say y1 equals that, y2 equals that, where does I go away? Or like why does it go away?
Yeah. When you write as a constant, it goes away.
Ah.
When you check the solution, it does not.
Right. Okay.
In both cases, you know, it's going to be good. Okay, so let's check how we're going to do it. We are going to ask you find the solution of, okay, example. Find the general solution. Okay, find the general solution. Okay, general solution of each equation. Of each equation. There you are. Number 1, y double prime plus y prime minus 6y equal to the 0. That's it. Is a differential equation of a second order with a constant coefficient. So for the characteristic equation and just the solution. Remember the way we do it? This is it. We start with the r squared plus 1 times r minus 6r to the 0. So that gives you the characteristic equation. Okay, is the characteristic equation. Characteristic equation. Okay, I've seen some people, they repeat this one again, even in your book. Y equal to the e to the rx, they differentiate it, but you don't need it. You just substitute because you're really full of this. Yes. Okay, that's it. Solve this equation, factoring most of the time. This is easy to factor, okay? So that gives you r plus 3 times r minus 2 equal to 0. So we get solutions. You may call r1 equal to the -3 and the r2 equal to 2. That's it. You have two distinct solutions. So from each one of them, this is just for your information. That gives you y1, which is e to the -3x. That gives you y2, which is e to the 2x, because the solutions are different. So the general solution is y equal to the c1 e to the -3x plus c2 e to the 2x, and then you're done. Done. Okay, in application problems, sometimes the equation is a function of t, then you have to write the solution in terms of the t, not the x. Yes.
Does it matter what order you put this, like what you?
No. All of them are going to be this. Okay, any question? So that was case 1. The solution were distinct, two different solutions. Okay, ready for the next one? Getting this one. Y double prime minus 4y prime plus 4y equal to 0. Again, as you can see, differential equation of a second order, constant coefficient, characteristic equation. What's characteristic equation for this one? R squared minus 4r plus 4. Okay, equal to 0.
You wrote r.
Oh, I'm sorry. Second. Okay, you factor it, you know that it's going to be a repeated solution. It's r minus 2 times r minus 2 equal to 0. So r equal to 2 is a repeated solution. Is a repeated solution. Or you can call it, r1 equal to 2, r2 equal to 2. So in this case, the solutions are going to be, the first solution is e to the rx, e to the 2x. The second solution, remember, is x e to the 2x. That's it. So y equal to c1 e to the 2x plus c2 x e to the 2x. And then you're done. Okay. So that would be case 2. Any question? Case 3. Case 3, you have a y double prime plus a y equal to 0. Let's check this one. What is the equation for this one? R squared plus 1 equal to 0. Start with r squared to the first and then 0. You solve this equation. You know that it's not going to be factorable. You move the 1 to the other side. You want to find the r, so r would be positive negative root -1. You know that this is I. So r is equal to the positive negative r. You don't have to consider both of them, you just pick one of them, identify the alpha and beta. Okay, so R equal to this is it. So R equal to the I, which is something like 0 plus I. This is the one you call it alpha plus beta. So your alpha would be 0, and your beta is 1. Where? There is no real part, so I call it 0. Because you have to identify alpha and beta. Because you want to write it down in the form of alpha plus beta I.
So beta is 1 and alpha is 0.
Yes, this number is imaginary. It's pure imaginary. There is no real part. Okay, any question? Now get the solutions. If you like, you can write the solution right away, but otherwise, the y1 is equal to the e to the alpha x cosine of the beta x. So alpha is 0, e to the 0 cosine of x, which is going to be cosine of x. You write it down right away. I just explained it. Okay, and the y2, same thing, e to the alpha x sine of the beta x, which is going to be e to the 0 sine of x, which is sine x. So the general solution is going to be y equal to the c1 cosine of x plus c2 sine x. So that gives you the general solution. Okay, so in the complex, this is the way you're going to write it down. And the complex is the one that you may frequently see in application problems. You should have a good feeling about it. Let's have another one. Any question? Again, these preliminaries, I just write it down for you to understand. But otherwise, you can list it right away when you get the solutions. You don't have to go through it. Okay, let's get the one which is a little bit more involved. So that was number 3, number 4. Okay. So what is going to be number 4? Number 4 equation is this one. 2y double prime, okay, plus 2y prime plus 3y equal to the 0. Okay, so this is going to be the case. Okay. So there's a 2r squared plus a 2r plus 3 equal to the 0. You have to use quadratic formula to solve it. Okay, quadratic formula, negative b plus or minus the square root of b squared minus 4ac divided by 2a. You substitute, you know that a is 2, b is 2, and the c is 3. So carefully substitute. It's going to be r equal to negative b is going to be negative 2 plus or minus negative 2 squared minus 4ac 2, 3. Divided by 2a, which is going to be 2 times 2. Okay, we just substitute, simplify it.
I mean, so then we have one in mind.
Oh, that's it, true. Yes, that 2 plus it. Okay, there's a negative 2 here. So simplify it. So that give a negative 2 plus or minus. Inside is 4 minus 24 divided by 4. So the top would be negative 2 plus or minus negative 20 over 4. Change it to the complex number. So it's going to be negative 2 plus or minus Okay, so that would be 20I squared divided by 4. So you have to simplify it a little bit. It's going to be -2 plus or minus. It's a radical 20. 20 is 4 times 5. So it's a 2 radical 5. 2 radical 5 times I divided by 4. Remember, no decimal number. You have to give us the exact solution. Okay, 20 is 4 times 5. So the radical 2, then we can break it and simplify by 2. So it's a -2 4 plus or minus 2 radical 5 over 4 I. So R would be -1/2. -1/2 plus or minus radical 5 over 2I. So these are going to be your solutions. Okay, just pick one of them, identify the alpha and beta, and then you write the solution right away.
We don't know we think great probability that this thing can be given in complex solution when they fall on.
The solution are complex. So that's a third possibility.
But we didn't use alpha or beta.
Hmm?
We did not use alpha or beta.
We haven't got to it.
Oh,
We get the complex numbers. You see I. So what's alpha? Okay, so we have used, we are going to use only one of them. Okay. Negative or positive doesn't matter. So yes, alpha would be -1/2. And the beta would be radical 5 2. Okay, any question? Now we are ready to give you the solution right away. So there you are. Y equal to the first one. C1 e to the alpha -1/2 of x cosine of the beta x radical 5/2 of x. That's the first one. Plus C2 e to the -1/2 x sine of beta x radical 5/2 x. Okay, so I just want you to know that this is a solution and this is the way we're going to write it down. Okay, so be ready for it. There are many cases, in case of the, especially in physics or engineering, electrical engineering. Most of the solution will be of this type when it's going to be complex. Okay, so don't change it to the decimal number. Exact. Yes. It doesn't matter. Both of them are the same. If you like it to be the same. Okay, so that's going to be the case. Okay, any questions? So be prepared for this type of representation of your functions. This is one option. Okay, get another one. Sometimes they may ask for an initial value problem. Remember, you have two constants, C1 and C2. So they may give you extra conditions. If they give you extra condition, you find the general solution, you have to continue to find the C1 and the C2, okay? And most of the time in application problem, this is going to be the case. So this is the number 5. Okay, so we have y double prime minus 4y prime plus 13y equal to the 0. But we're given extra condition. The extra condition are y of 0 is equal to the -1 and y prime of 0 is equal to 2. Remember, is an equation of a second order. So you have two constants, so you need two initial conditions to be able to find it. Okay, solve it first. Get the general solution, then come back and identify the C1 and the C2. Okay? So start with your characteristic equation. What's characteristic equation for this one? R squared minus 4R plus 13. Okay, that's it, equal to the 0. This is going to be the case. Again, you have to use quadratic formula to get it. But the solution are not going to be real. Okay, so A1, B negative 4, and the C of the 13. So R is equal to negative B would be negative 4 plus or minus the square root of B squared negative 4 squared minus 4 AC. 4 times 1 times 13. Okay, divide by 2 times 1. Therefore, you simplify it. What are we going to have? So the top would be 4 plus or minus inside. Negative 4 squared would be 16. 16 minus 4 times 13, 52. Divide by 2. But if you simplify it, so that give you 4 plus or minus the square root of negative 36, which is a nice number, okay, over 2. So we change 36i squared, so that gives 6i. So it's going to be 4 plus or minus 36i squared, okay, over 2. So that gives us 4 plus or minus 6i over 2. You have to break it, write it down in the form of alpha plus beta r, complex number. So it's going to be 4 half plus or minus 4 2i. Simplify it. So that gives you 2 plus minus 3i. So this is going to be the true solution that we have. Okay, you take one of them to identify your alpha and beta. So alpha is 2, beta is 3. Okay, so we take the alpha equal to 2 and the beta equal to 3. Write the general solution. Okay, so this is the general solution. Y equal to the C1, e to the alpha x, e to the 2x. Cosine of the beta, 3x, plus C2, e to the 2x, sine of the 3x. You see, this is the general solution. So this is the general solution. But we have initial condition. Okay, you have initial condition, you have to impose that initial condition to get it.
So why is it that we can say beta is just 3 and not -3?
It doesn't matter. You like -3, take the negative.
Okay.
Because you know that the cosine of the negative data is the same as the
Yeah.
cosine of the data. So that's why it doesn't. Okay, so that's a general solution, but we have initial condition. Initial condition, y0 equal to -1. So you put the x equal to the 0, you let this one to be equal to -1. But the second condition is y prime. So you have to differentiate it first, then substitute to get the, okay, the second equation, then system of the equation give the job, okay? So I've done, go to the next page to continue to get these two conditions. Okay, so apply the condition. The condition is y of 0 equal to the -1. Get this one first. So this means you put x equal to the 0 and replace y by -1. So it's going to be -1 equal to. If you put x equal to the 0, that the top one would be 0. You say it's going to be C1 e to the 0. Okay, then we get the cosine of the 0. And we get the C2 e to the 0. And we get the sine of the 0. Okay, sine of the 0 is 0. So the second one will disappear. Cosine of the 0 is 1. E to the 0 is 1. So that gives us simply -1 equal to C1. Or C1 is equal to the -1. So that's what you get from the first one. Or otherwise, you write it down and wait for the second equation. Okay, so I impose y0 equal to -1 into the equation. Any question? Now you want to impose the second condition, you have to find the y prime first. Because you want to apply y prime. Okay, find the y prime. Differentiate the solution that we have. It's going to be y prime equal to derivative of the first one, exponential function. 2c1 e to the 2x cosine of the 3x. Okay. Yes, yes, brother. No,
Plus 3 even 2x cosine or negative, oh, minus
the cosine of the 3x derivative would be negative sine, -3, okay? So it's going to be minus. Derivative of the second one, 3 c1 e to the 2x sine of the 2x. Okay, that's for the first one. We have to repeat it for the second part. The same thing for the second part. So it's going to be plus the second one, 2 c2 e to the 2x sine of the 3x. Then we come back again. If we have a sine with the 3 cosine, so that give you plus 3 c2 e to the 2x, but cosine of the 3. Okay, you have to apply the product rule for each term. Okay, now quickly impose the condition. You don't have to substitute anything or simplify. Just leave it, then it would be out. So the condition was y prime of 0 equal to 2. So this means 2 equal to. Okay, 2 equal to, if you put the 0, okay, for the first part, so that give you 2 c1 e to the 0 cosine of the 0. The second one would disappear. Okay, you don't have to write it, but just write it to explain. This would be out. This would be also out because of the sign. Get only the next one. 3c2 e to the 0 cosine of the 0. Okay, sine of the 0 is 0. So these are would be out. The cosine is 1. So the conclusion is 2 equal to the 2c1. Okay, 2c1 plus 3c2. There was a negative sign that I missed. Yes, where is the negative?
The minus 3. So the
No, they are all seems to be all right. Which one?
plug-in C1.
Oh, C1 is negative 1, yes.
Yeah.
So C1 is negative 1. So it's going to be 2 equal to the negative 2 plus 3C2. Okay, 3C2, so 3C2 equal to 4. C2 would be 4/3. Okay, so C2 is 4/3 and the C1 is negative 1. Now we have to write the final answer, the particular solution, y equal to C1 is negative 1, so negative e to the 2x cosine of the 3x. That's a C1, and the C2 is 4/3. So it's going to be plus 4/3 e to the 2x sine of the 3x. So that would be the particular solution that they ask for. Okay, so be ready for it, for this initial value function or problem. Any question? So this is just the second order. Now what we can do is we can extend it a little bit. It's the second order. How about the third, the fourth, the fifth? Okay, it can be done. So we give a couple of examples. We're not going to wait for the other section to talk about it. Just do it over here. But basically, we are concentrated on the second one. So This is it. I'm going to change it so that you know they are different. Find the general solution. The general solution of each equation. Okay, so I'm going to raise the order. It doesn't matter, it's going to be the same thing. Your only difficulty is when you form that characteristic equation, your difficulty is solving that equation, okay? Any equation can be solved because you can have complex solutions, okay? Some of the equations are a little bit more involved. You may use something from, algebra to be able to solve it. Let me give you some very mild one, okay? But you may get a couple of them in your, in your book, in your assignment. Let's try this. You see the popular one is of this form, y triple, if you like, the third, the second, the first, and the y. You see this equation? It's a homogeneous equation of the third degree because the first part, you start with the y here. It doesn't matter. Change it to the characteristic equation and we do it for the others, okay? What's the characteristic equation for this one? Solution r cubed minus r squared minus r plus 1. You see, this is going to be an equation. Now you have to solve it. Factoring, or that. There is no common factor here. Any suggestion? I'm going to solve this one, to factor it.
Like the one to the other time that you can allow.
Factor by
Very bad. No. You never change the zero. When you want to solve the equation, you must have zero all the time on it. Yes, you cannot use the factoring, but how many terms we have? 4. So when you get an even number, you try grouping them. Okay, try to group them together. Okay, to find the common factor, you group the first two and the last two. Okay, for the first one, you factor out r squared. So that gives r minus 1. For the second group, you need r minus 1. So you factor out the -1 or the negative sign. So that gives you r minus 1 again. So we have a common factor. Common factor is r minus 1. So that gives r minus 1 times r squared minus 1 equal to 0. That's it. Let each factor to be equal to 0 to get the solutions. We expect 3 solutions. So the first factor would be 0. That gives you r equal to 1. The other one, r squared minus 1 equal to the 0. You know that r squared equal to 1. So that gives you r equal to positive -1. So your solutions are going to be 3 solutions, remember? So the r is equal to the 1, 1, and -1. So this means you have one distinct solution, which is the -1, and you have one repeated one. Now you need 3 solutions. Okay, any suggestion? The solutions are going to be y equal to. Yes.
The negative x and x.
That's it, yes. For the first one, r equal to 1, that gives c e to the x. Since it's a repeated one, we repeat it, but we multiply by x. So that gives you c2 x e to the x. So that will take care of this first two. Then we get to the -1. It's a c3 e to the -x. So this would be the final answer. Okay? So it's the same thing. If it's going to be for each solution, you are going to have e to the rx. If it's going to be repeated, you repeat it. It depends how many times. In this case, you see, you just repeated once. So you get e to the x, or twice, e to the x and x e to the x. But you are fine because the degree of the equation was 3, the order, and you get 3 distinct solutions. Okay? So this is going to be one version. Any question? Let's give you another one. This let's see. There are a number of them. Let's try this one. I should give you this one at the beginning, but just start with the other one. Okay, this is it. 3y double prime, and this is going to be minus 4y. Okay, that's it. 4y equal to the 0. How about this one? What is the characteristic equation?
Plus 3r squared.
R cubed plus 3r squared minus 4 equal to the 0. Okay, how are we going to factor this or to solve this equation?
Oh, just kidding.
No,
Yes, you cannot factor out the R. in it. Yeah. Any other idea?
Calculator.
Of course.
Divide by.
Synthetic division. Rational root theory.
Of course, that's one. Yeah, you can use the rational roots theorem, or you see for this type of problems, first thing to check is check to see if the sum of the coefficients happen to be equal to the 0, especially for this type of equation. The sum of the coefficient is 1 plus 3 minus 4, which is equal to the 0. If it's going to be the case, R equal to 1 is always one of the solutions. Then we can use this one to get the other ones. So it's like the special case of the rational 0 theorem, okay? But most of the time you have it, okay? Sum of the coefficients. This means R equal to 1. Substitute R equal to 1. That gives you 0 all the time. So it's the case for this type of equation. That give you a hint. Okay? So that's it. 1 plus 3 minus 4 is 0. So R equal to 1 is one of the solutions. Then you can use, if you like, synthetic method or just divide it to get the others.
And what's the rule for us to be allowed to do that?
This one?
Yeah.
It's a general property of the equations all the time. If the sum of the coefficients of a polynomial is equal to the 0, one of the solution is 1.
Okay.
Because if you put R equal to the 1, that give you always the sum of the coefficient.
Yeah.
That's why. Yes, that's the question. So am I the synthetic method to find it or just factoring? Remember synthetic method? The way you are going to do it to factor it. Yes.
Can you like say it again? Because the sum of what equals to 0? I want to write it out.
If the sum of the coefficients of an equation, of a polynomial, if you like, is equal to the 0, R equal to 1 or X equal to 1 is one of the solutions all the time. This is the way we check. Okay, we check quickly to find out. You know that the rational 0 theorem in algebra is this one. You see the 4 here? We are going to check the divisors of the 4. 4 is divisible by what? 4 divisible by 4 is divisible by 1 and 2 and 4 and no, it's not divisible by 3. No, it's a positive negative 1. Positive negative 2, positive negative 4. So these are the possibilities. So the solution must be around here. Okay, this is the way we do it in algebra. You need the first one. So the first one, you already got it. So synthetic method. Remember synthetic method? You want to divide, this is it. You start with the 1. So you list the coefficient of your polynomial. The coefficient of r cubed is 1. The coefficient of r squared is 3. The coefficient of r is 0. The constant term is a -4. You bring this 1 down, and then you multiply. 1 times 1 is 1. You add these two together, that gives you 4. Okay, then you continue. 1 times 4 is 4. You add it, we get the 4. 1 times 4 is 4, you get 0. So this means yes,
Can you start over and explain that again?
no,
No?
you must know it. Yes, I explained. Okay, the way you do it.
Okay, I was like, right, I appreciate that, sir.
Okay. Now, the way we do it is this, you see? This is the same as the line division that we do.
Okay.
When you do the line division, it's just the numbers. So this is the way we do it. You put the 1 here.
Should I hear that right?
Okay, you put the 1 here. Then you list the coefficient. You see the coefficient of R3 is 1. R squared is 3. You must have the list of all of them. You need the R here. The coefficient of the R is 0. Then the -4. You bring this first number down, 1. Then you multiply, you see, you put a line here. Then you start multiplying. 1 times 1 is 1. So 3 plus 1 would be 4. Then you repeat it. 1 times 4 is 4. 4 and 0 is 4. 1 times 4 is, okay, this is it. 1 times 4 is 4. -4 and 4 is 0. This is the remainder. This is the quotient, the result. So you start with the r cubed. So this would be 1r squared plus 4r plus 4 equal to 0. That would be the leftover. Or you can divide it. Just divide it by r minus 1. Yes.
One of them left from R equal to 1, or is it always?
No, it's r equal to 1. Because we're checking the 1. If it's going to be any other number, you put it over there. Syntactic method. Syntactic division. Okay. Okay, so the leftover is this one. You solve this equation. You know that this is can be solved easily. Okay. So you are going to get a repeated solution here. R equal to the -2 is going to be a repeated. Okay. So this is going to be a repeated solution. Is a repeated solution. So what you have? You have R equal to the 1, -2 and -2. Now we can write the solutions. It would be very useful, you know, in your book, they don't elaborate on this type of method. Otherwise, you should have, you know, something like that you have to find the something that we call it zeros of the complex numbers. We used to teach that. Okay, we teach that before getting to these equations because we need it. This is what you need if you are measuring, you know, physics, engineering. You have to find it. Okay, then I used to teach it, but you just go with some easy part over here. Okay, so now we can have the solution. What's the solution now? C1 e to the x plus e to the -2x and x e to the -2. So that would be the solutions. Okay, I give a break now. We will go over it, you know, later on we may talk about it. But you don't need, you just give you the hint. Okay, in case you want to do it in future, these are the two that's going to be available. But we go with your book. The second order. Let me give a couple of easy ones. Okay, that's 10 minutes. We come back and we check to see how we're going to solve the non-homogeneous one. Okay, so this is homogeneous. Yes,
Sorry, what is, what comes after C3?
X is negative two X is negative two. So one of them is e to the negative two X, the other one is X e to the negative. And it's a repeated multiple.
Professor, this was some perfect timing.
Huh?
Today in my discrete class, we just did, what's it called? The relation, with this equation.
This type of.
Yeah, we did that
recurrence
today.
defined?
Yeah,
Yeah,
we do that today.
Yeah, yeah.
Like you're the second.
Yeah.
Same topic.
I was like, oh, this looks really familiar, and then he's like, oh, I just.
If they over here, we say e to the R X, over there, we say R to the N.
Yeah,
R one to the N, R two to the N.
no, I get
That's similar.
computer engineering.
So
Yeah,
it's very, very similar.
Yeah, he like, he was explaining it, and I was like, wow, this is really familiar, why haven't I seen this before? And then he's like, oh, you see this in the screen now, it's called, recursive
Yeah.
relation, I was like, oh, I just did that today.
Yeah, so. That's nice to see these, these connections.
Yeah.
They were great. That's all because of the computer science.
Yeah.
In the old days, this was the classic one. And the other part is the modern one. When you go to the sequences, okay. the process-
Well, yeah, it makes recursion easy, because you don't even
Yeah.
need recursion after that, you
That's
just
it,
put
yeah.
an equation, it's faster and more efficient.
Oh, yeah. What is your name? Okay, I'll check that. Make a note and I'll give you a point.
Thank you.
Okay.
Yeah, no, like an alcohol. I don't think so like that. Really weird.
Okay, so what we are going to do in the next step. This equation that we did solve, they were all homogeneous. How are we going to solve a non-homogeneous one? Of course, with the constant coefficient, it's still with constant coefficient. So you know that you have to find one of these particular solution, YP. If you find the YP, okay, if you want the YP, then YC plus YP is going to be the solution of your equation. There are eventually there are two different methods that we're going to apply in your book. We talk about a couple of them, but basically they are going to be the same. It's the two methods. And so this method that we're going to determine is very limited but very useful. So the differential equation will be given to you. You see, this is the we explain the idea, then I write it down for you. You see the yes.
Is this still 4.4?
No. Okay, so this is going to be the idea. Okay, when I write it down to you. So we are going to be staying with that equation that we do. You see, that's a 1. That is not going to be 0. It's going to be a function. Okay, so this is a none. In order to solve it, you know, the general solution of this equation is going to be 1c plus 1p. Remember, we proved this. YC is going to be when the left is equal to 0, and we'll talk about how to find it. The YP is going to be the particular solution of the. Okay, so if you want to solve it, you make it 0 first. Okay, divide the solution that we discussed tonight, that will be YC. So we need to find this YP. How are we going to find the particular solution of this equation? Okay, the method that we're going to use is very limited. The limited means this function over here, most of the time, it's going to be a polynomial. If it's going to be a polynomial, if it's going to be an exponential function, into the order, if it's going to be the sine or cosine, you get it. With this one. So it's limited. If they give you equal to the secant x, you can't do it. Tangent x, you can't do it. We're going to have another method in future. We call it, okay, change of parameter, variation of parameter. Quite nice. Yes,
Just to clarify, YC is when you make it equal to 0.
that's it. YC for the general solution. We proved this one. YC for the homogeneous. So we can do this problem only with this condition. The condition is this R of x is going to be a polynomial. It's going to be e to the Rx. It can be sine of the beta x, or it can be sine of the cosine. This is the only possibility. You know that the polynomial depends on the degree. So the polynomial in general is what? A0, A1x, A2x squared, up to the AN x squared. That's a polynomial. You see, the idea of this method is we call it undetermined coefficient. Undetermined coefficient, we focus on this one. You see, the polynomials are all the same. The only difference are really the coefficient. If you want to write a quadratic one, you say this is going to be quadratic. If you want to write another one, you change this number. Okay, so that's the idea. So what we're going to do, we are going to guess the solution is going to be like a polynomial. That is a polynomial that we don't know the coefficient. So that's why we call it undetermined coefficient. So the way we do it, if this R of X is given to you of this form, so what you do, you call your YP. Your YP would be the same polynomial with the unknown coefficient. So if this is going up to the end, you write another one. But we don't have this number. We're going to call them, for example, we say A0, A1X, up to the AN, etc. You see, this is going to be the suggestion for your YP. So for example, if this is going to be your polynomial is this one, you see? So your solution must be the same polynomial with different coefficients. So suggestion is this must be A1 x squared, A2x plus A2. But what you are going to do, you have to find the A1, A2, A2. How am I going to do it? You substitute in this equation. You got to be very patient. Okay, you find the first derivative, second derivative, you put them over there, and you find the coefficient right away. That's the base here. If it's going to be e to the Rx, e to the Rx is e to the Rx. Only the coefficient is different. So depends what you have here. This is a constant polynomial. So you write A1 e to the. If it's going to be a polynomial times e to the Rx, it's going to be a polynomial times e to the Rx. It's going to be a little bit more and more. Sine cosine, polynomial. If you just sine 2x, so you just change the coefficient. Okay, we call it undetermined coefficient. So you're going to change the coefficient into the unknown, then you substitute in the equation, it's the line procedure, but it can be done. Okay, I'm going to write it down. Okay, there is only a catch over here when you do this type of problems. You see, then you go back and you put this one into this equation here. If when you solve the YC, it's called the YC, and you form the YT, if one of these term over here, it will be repeated in your YC. So for example, if you have YC for the okay, C1 x squared plus 5x plus 1. And if you have a x squared over here, remember x squared is the solution of the homogeneous one. So automatically when you substitute everything will be cancelled out. You don't have, so you got to be careful. You have to avoid the duplication stuff. How can you avoid it? If there is x squared here and x squared here, you raise the power of your volume. You multiply it by x. So if this is going to be x squared and you multiply by x, you end up with x cubed. No more x. So this is the only one. But if you miss it, you substitute, you get 0 on one side, you get something in number of the other. Otherwise, it's very nice. Okay, so I'm going to explain it, classify it for you, and then we try to do it. We ask two types of questions over here because the procedure is very long. So what we do sometimes we ask only for the form of the YP. You just tell us the form, don't solve. Then it's we higher, it takes time. Maybe 20 minutes to solve one question. And so one of them is the form, the other one is when we say solve the equation. So this will be up to them. So those solving the equation are very short, but we check everything. Okay, so you can have 2 or 3 questions for the next week. So that's the idea of the undetermined coefficient that you are doing. Okay, if you have up the science measure, same thing over there. You don't have the sign and the cosine in those things. You have only exponential function. Recursively defined sequences in computer science. Okay, so I have to explain a couple of things and then you'll be able to do it. Okay, so this is section 4.5, I believe. No, the 4.3 was the homogeneous is a 4.4. 4.4 in your book, they give you 2 different approach to this problem. You don't need to know those 2 operations, okay? One of them is very good idea of the linear algebra, if you are interested in those type of things. But we are not going to cover that one. It's a 4.4 only, okay? 4.4 and the method of, that's it, 4.4. 4.4, we call it undetermined. Okay, this is it. This is going to be undetermined. Okay, undetermined coefficient. Undetermined coefficient method. Okay, undetermined coefficient method in order to find a particular solution. I'm going to explain it. So that's the name of the method. You have to recognize it yourself. Okay. And so the restriction first. This method, the undetermined coefficient method, okay, can be applied. Can be applied to find a particular solution. To find, okay, a particular solution. Particular solution YP of a second order. We can do it for the higher order, of course. A second order differential equation. Differential equation. This is the differential equation that you can apply. Y double prime, AY prime, sorry, AY double prime, BY prime, CY equal to the R of X, not homogeneous, because you want to find a particular solution. Okay, so to find you see YP, a second order differential equation, in which, if you like, you have the following condition. The condition is going to be the first one. We already talked about it, coefficient must be constant. Cannot use it otherwise. The coefficients are constant, as I put it on the chart. Second one, this Rx can be only of the following. Rx is a polynomial. Is going to be a polynomial, an exponential function, an exponential function of the form e to the, okay, e to the alpha x, Rx, it doesn't matter, e to the Rx, sine function, sine of the beta x, or cosine function, or cosine of the beta x. You cannot use it for any other type of the function. You see, polynomial, exponential function, sine function, or the cosine function. This is the only possibilities. Okay, apply the following table if you like. Apply the following. Just give you classification following the table. So I give you all the possibilities that you can have. So if you like, this is the table that we're going to have. So in the first part, we are going to introduce the function R of X. And in the other part, we get the form of YP. Just a couple of cases. The case one, polynomial. If this is going to be a polynomial of this type, You see the polynomial would be a0, depends on the power, a1x, a2x squared, you continue. It's going to be just, a couple of these steps. But if this is going to be a polynomial, so what you are going to do, you are going to change the coefficient. So you change the coefficient into unknown. A0, A1x, A2x squared. You keep going, depends on the power of the given polynomial. So that would be the form of the type 1. So if it's a polynomial of first degree, you write a general polynomial of the first degree. But the given one, the coefficients are given to you. But the one that you propose, you have to find the coefficient yourself. So you call it YP, then you go to the equation to find it. Yes.
If in some cases we need to increase the power of, or increase the degree of our polynomial, why don't we just write x to the n plus, or to the n plus 1? Why don't
No,
we
you
go?
have to wait. I tell you what we are going to do for that. It would be different thing, not that. The one that I talk about it, you multiply all of them by x.
Hmm.
Then that will take you to the express one. But this is general. Then we explain. Okay, we write it down first, then we check. You see, if this is there any repeated solution, then we do it. Let's list that first. Yes, we'll check. Okay, now the second type. The second type is going to be if you get a sine function, you see, if you have something like a sine, just sine of beta x. So if you have the sine, you have to write a combination of sine and cosine. So it's going to be a sine of the beta x, for example, plus, for example, you see b or a1 and a2. I go with the a1, a2, but it's a b cosine of the beta x. Because the sine and the cosine are coming together. It's the same if it's going to be cosine of beta x. So you write the combination of sine and cosine again. So the coefficient that's going to be determined are going to be a and b. Okay, so the sine and the cosine, the combination will be the same thing. So this is when it's a constant, but you can have a more general term. If you have something, a polynomial, you see, if you have a polynomial, you have x cosine x, okay, x squared cosine. If you have a polynomial, to the n times sine of the beta x, so it will be a very, very large one. You have to get a polynomial a0, a1x, up to the an x to the n times the sine of the beta x, and then you have another combination for the cosine. So you have something like the b0, b1x, up to the bn, x to the n, cosine of the beta x. So it depends. If the coefficient is a number, you change it to the number. You will see then you write down, yes.
I can't read, what is that, a naught?
Polynomial, a0, a1x, a2x squared, etc. A0, a1x, a2x squared, like the one that I put on the top. I just repeat this.
Sine, the one after the bracket, sine prime beta x.
No, it's a sine beta x. There is no sine prime. It's just sine and cosine. Okay, it's going to be the same for the cosine. So if they give you the cosine, it's the same thing. A0, A1x. You don't need it, but I just write it down to have a complete list. Cosine of the beta x, same thing. So it's going to be the same thing. We repeat it. Sine of the beta x plus b0. You are going to have just a couple of them. But let's have a record of all of them. It's all polynomials that you change the coefficient of the polynomials together. The last one is exponential function. So if you have a polynomial, like the same thing, a1, x, a to the xn times exponential function. Okay, e to the rx or alpha x, it doesn't matter. Then you do the same thing. A0, a1x plus an x to the n times e to the alpha x. Yes? When you have e to the rx, what is the coefficient? 1. So what's going to be the polynomial for 1? A1 is a constant. See, 1 is a constant number, we need a constant. That's 1. Okay? If it's going to be x, you see x e to the 2x. X is a linear polynomial. And it's 0 plus b1x. Okay, most of the time it's a number or it's x, but we write it on here. Okay, so these are going to be all the possibility, but the catch is going to be when you write this one, you have to go back and check the YC. If there is going to be a duplication there, if there is going to be a common term in both of them, you have to come back and raise the power of your polynomial. Raise the power of your polynomial means the total that you have over here, you multiply by x. If you need it, you multiply by x squared. Okay, so the catch is going to be this one. And this is the one that you may miss. Note that. Okay, I'll give example. Note that 2 cases. If YP, the general solution, contains, okay, it contains terms that, okay, terms that appears, if you like, in YC or duplicated. Okay, we call it a duplicated term. Duplicated terms. If they have the common term, the same term, then you have to raise. Okay, then YP must be multiplied by a proper, okay, power x. You may need x squared, you may need x cubed, etc. So you may multiply by x, then you are not able to remove the repetition or duplication. So you raise the power. I'm going to do it in a minute, you will see it. That's going to be one. The other one is sometimes this R of x is a combination of a couple of functions, g1 plus g2. You may get a polynomial plus sine, cosine. You do it one by one. If this is going to be the case, let yp to be equal to the, okay, we call it yp1 plus yp2. So you do it once at a time, or one at a time. Write it down and give example, then you see how we're going to operate. It's a very easy method, but it takes time because you have to find this coefficient. In order to find the coefficient, you have to go back and substitute the yp into the equation to be able to find the undetermined coefficient. Okay, so let's give an example. Let's determine some of yp first without solving it, and then we come back and we do the solution. Okay, there you are. 2 types of problem. That's the type 1. Determine the form of a particular solution. Means YP. Particular solution of each equation. Remember, they ask for the form only. We don't want you to solve it. Just give us the ball. Let's practice first. Here you are, the first one. Y double prime plus 4y equal to x cosine of x. That's the one. They ask for the form only. First, you have to find the YC. Because you want to check to see if there is any duplication. Okay? So it doesn't matter whether you want to solve the equation or just give us the YP. You have to solve the homogeneous equation first. Okay? So first thing to do, solution. Solve this equation. You already talked about it. You know how to solve it. Okay. What is going to be the characteristic equation for this one? R squared plus 4 equal to the 0. R squared equal to the -4. You know that R squared equal to the 4i squared. So R would be positive -2. Complex solution. Identify alpha beta and write the YC. So we pick the R to be equal to the 2i. You know that this is like 0 plus 2i. So your alpha is 0. Your beta is 2. Give us the solution. YC equal to, remember, C1. C1 e to the alpha x, which is going to be just 0. Cosine of beta x 2x, which is going to be, I'm sorry, it's going to be plus. Okay, plus C2 e to the 0 sine of the 2x. So YC would be what? C1 cosine of the 2x. Okay. C1 cosine of the 2x plus C2 sine of the 2x. So this is your YC. Okay, so we find the YC. Yes, what's the question?
So this is not a repeated solution, right?
We check to see if it's going to be repeated solution. Yeah, you have to check it first. Let's write it down, we check.
Sure, but.
Okay, so we are going to identify the YP. What's going to be your R of X? R of X is equal to X cosine of X. So polynomial is X, and you have a cosine. Remember, what is the case? When we get the sine of a cosine, is a combination of sine and cosine. Your polynomial is a linear polynomial. Degree is 1. So this is the way you're going to write it down. YP equal to, you change the polynomial, a general polynomial of the first degree. It's going to be what? It's going to be, you know, you can use A, B, C, but I'm going to use A1, A2, A3. So it's going to be something like A1 plus A2x. You see, since it's an X, I write the general one. It must be times cosine. Remember, since it's a cosine, you have to repeat it, a combination of sine and a cosine all the time. So I go with the A2 and the A2, so I go with the A3 and the A4. Sine of X. So I write it down. Some people, they go with the A and the B, doesn't matter. Okay? So I just change the polynomial. The given polynomial is a linear polynomial. I write a general linear polynomial. So general linear polynomial times cosine, general linear polynomial times X. Now check. The checking one is there any duplication? Any term of this is repeated in YC over here. You see the YC is sine of the 2x and the cosine of the 2x. Nothing to do with the second one. Yes?
It's the form, doesn't it need to be beta X
Which one?
for the sine side? the quantity of side is stated.
No. Because your beta is 1. You see, you focus on this, the cosine that's given to you.
Oh, I see.
Okay, that's 1.
Will A4 be multiplied by L?
So let's see, if you compare them together, you see, if you compare them together to see if there's going to be any repetition. In the YC, you have sine of the 2x and the cosine of the 2x. Nothing to do with this one, because this is sine x and the cosine x. So there is no duplication over here. So this would be the general form. Any question? This is the way we operate. Yes.
In the second term, hold on, take a solution. We have A3 plus A4.
Yeah. A4x, A4x. X. These two are going to be the same. X. You see whatever polynomial, you see this is a linear polynomial, you write a general linear polynomial. General linear polynomial is like mx plus b. Okay, so it's going to be a1 plus a2x. The duplication must be the same term. You see the term is on the YC, you have sine of the 2x and the cosine of 2x. But in your case, you have cosine x, nothing to do with your term. So that would be the one. If you want to find it, of course, take time. You have to put this yp in the given equation. You have to find the first derivative, second derivative, put them equal to each other, and eventually find it. We're going to solve one of them, but no problem. They ask for the form and we done. Yes.
General form YP plus YP?
Sorry?
Isn't the general solution YP plus YP?
Yeah, that's the general solution. But we are looking for the configuration. YP is a good. Any question? Ready for yes.
So what was the condition again that we have to check?
You see, look at this one.
Mhm.
If this was cosine of the 2, this is the given one.
Right. In that
So
case,
what we're going to do, we're going to put the parentheses around all of them, we multiply them. Okay, so when you raise it, if you're going to raise it over here, that is a1x, for example. Okay, then even if a1x, you see, you remove the repetition. But since that's the cosine of 2x and the sine of 2x, there is no repetition.
therefore it's different.
So that is the actual solution.
Thank you.
Any question? Easy. Let's have another one. Okay. Yeah, we are going to practice. You build this through. Okay. Let's give you another one. More exciting one. Okay, how about this one? Number 2. Y double prime minus 8 y prime. Okay, plus 25y equal to 7e to the negative x. That's the next one. First, you have to find the YC. You see, you need the YC to see if there is any duplication. So let it equal to the 0 to get the YC first. Solution. Solve y double prime. You can start, by solving it, but I explain it. What's the characteristic equation? R squared minus 8r plus 25. 25 equal to the 0. You have to solve this equation. Okay, you cannot factor it to quadratic equation, quadratic formula. So that give you negative 8. Okay, plus or minus b squared, negative 8 squared minus 4, 125, 2. So that give you 8 plus or minus 64 minus 100 over 2. Okay, so that give you what? 36. Negative 36 over 2. We change it to the complex number. So that give you 6i over 2. You break it. So that give you 4 plus or minus 3i. Okay, so this means they are not going to be repeated one, but we have to write it down. Alpha 4 beta 3. So the YC would be C1 e to the 4x cosine of the 3x plus C2 e to the 4x sine of the 3x. This is your YC. Okay. Bring R of X, find the YP. Okay, are you done? I'm going to go to the next page. R of X is 7 e to the negative X. Very easy function. So we can do it over here. R of X, 7 e to the negative X. Exponential function. That's it, YP. You see, the polynomial is a constant polynomial. Just A1. A1 e to the negative X. Compared with the YC, nothing to do with the YC. So this would be YP right away. There is no duplicated, duplicated term. Yes? You see, your R of X is exponential function. The coefficient is constant. So you need a constant polynomial. You replace the 7 by A1. Okay? And your YC, nothing to do with this one. Okay, so that would be your YP. Okay, let me give you one, the last one that you need to change it. So it's not going to be a difficult one, but your challenge is the next one. Number 3. How about this one? Y double prime minus 2y prime plus y equal to the e to the x. Let it equal to 0, solve the homogeneous one. Okay. Solution. Characteristic equation. R squared minus 2r plus 1 equal to the 0. Of course, we are solving this one. I'm sorry. Solving this. That's easy. It's r minus 1 times r minus 1 equal to the 0. So we get the repeated solution. So we're going to be r equal to the 1, 1. So what's going to be solution? YC equal to solution C1 e to the x. Second one, C2 x e to the x. That's a YC. Remember, it's a repeated solution. So the first solution is going to be e to the rx. The second one is 1 by x. Okay, any question? During the Rx, give us the YP. What's the Rx? E to the X. What's the coefficient? You go with A1 e to the X. Check if it's going to be all right. E to the X. There is a e to the X over here.
You have to raise the power twice, right?
So yes, we are going to raise it once. We multiply by x. We check again. We have x e to the x. X e to the x is also here. So we have to raise the power. A square. Okay, so that would be your YP. YP is A1 x squared e to the x. And you got it. You have to check. You see, you cannot have a repeated solution. So when you write it down, you go back and you compare it to the y. That's why you solve it. Okay, so e to the x is here. So you have to change it. This is a1 e to the what are the x e to the next one. But x e to the x is here. Multiply by another x. X e to the. So you have x that's going into the a, which is not duplicated. If you miss it, you go back, you substitute, everything to the left will be true. There is no A1 for you to find. Then you find out that you made a mistake, and you can't have it. It's the only thing. Yes,
So we have plus C3 x squared given the x,
it doesn't matter if you make it.
would be multiplied by x
You
cubed.
can multiply by anything you like. You need, you multiply, you remove the duplication. It depends. In the case of the second order, you duplicate after the x into the x. So there is not going to be any more power. But if it's going to be higher power, you may have some reverse. Okay, so make sure you don't miss, especially with the e to the x, they usually ask you to solve it. But that's easiest case to solve. So if you miss it, go back, you see, because this is the y here, remember? So this is the solution of homogeneous equation. So if you repeat this one, it's like substituting y1 in the equation. If you substitute y1 into the equation, so first part will be 0. So you get 0 on one side, some we get from the other. So you have to come back. And do it. Okay, so we give them all example next time. And we try to solve it, okay? With the higher one. So when we done that, then we are done with the case with the constant coefficient. Then you have to consider when the coefficients are not going to be constant, okay? We get a couple of more sections to finish. Okay. So I give you an example. I'm finding this coefficient next time. We're not there yet. Okay, that's it.